Hello guys and welcome. In this lecture we will see how to use image filtering, or how to filter images with OpenCV. Let me first create a Python file. I will call it image filtering.py. So the image filtering helps to, if it is low pass filters, it helps to remove noises from images by blurring them, or if it is high pass filters, it will help to find edges on these images by sharpening these images. Let's see them in practice. I will import CV2 and numpy as np. So I will read an image from the data. You can read any image. I will read here the OpenCV logo, and let's first start by blurring or smoothing images. So we will use cv2.filter 2D, and this filter to take the image, and the depth, it will, if we want the same depth of the image, so it will have 3 channels, we should give it -1. And the kernel, we should define here a kernel, so I will define here kernel, which will be np.once with size of, for example, if I want to get a kernel of 5 by 5 with np.float type of the elements of this array. So I will choose float 32, and we should divide by 25. This 5 times 5 is 25. We should divide by this to get a normalized array, which sum to 1. And then we should use this kernel here. The returned image, I will call it, for example, blurred, and we can show it here in show. Let's first show the original image to compare with it. Original and image, and cv2.imshow blurred image, and call this blurred here. And we can do cv2.waitKey 0 like that. Let's run the code and see the result. Python image filtering.py. So this is the blurred image, and this is the original image. If you can see, if you look at here, you can see that it is it adds some noise on this image, and we can augment this noise or make it or diminish it by changing this kernel. So if I give it, for example, a kernel of 3 and 3, we should divide here by 9. So in that case we will have less noise on the image. While if I give it more or a bigger kernel, I should divide here by 49, it will get more noise and the image will be blurred like that. Of course, you can give any odd numbers here, so 9, for example, 9, and divide here by 81, and in that case it will be blurred more and will have more noise on the image. We can use the same function to sharpen the image, but we should change for the sharpening, we should change this kernel and give it a high pass filter kernel. So I will define here kernel 1. If I call this kernel 1, and this kernel 2, and change it like that, saying np.array. So we should give it an array like this one, for example, 0, -1, and 0, and this will be a 3 by 3 array. So, and -1, 5, -1, and the last array is 0, -1, and 0. So this is one type of the sharpening kernels that we can use to sharpen the image, and calling this function cv2.filter2d, give it the original image with the same depth and the kernel 2. The resulted image, I will call it sharpened, like that, and I will show it also here, cv2.imshow sharpened, and call this image. Let me make this, for example, 3 and 3, or 5, 5 to have a reasonable one. So now we can run the code and see, you can see the difference between the original image and the sharpened image. So now it is, we can see more edges and details on this image than the original, and of course the blurred image is, it has more noise than the others, like that. You can also apply these methods on another images. So for example, if I use the cdco png and run the same methods like that, so you can see the sharpened image, this blurred image, and the original image. You can see here that in the sharpened image we have more details and we can detect the edges of this image easily, and in the blurred image we have here a noisy image compared to the original image.